All right, folks, welcome to my session here at StirTrek. I'm going to be talking today about retrieval augmented generations. We have an introduction to RAG. I'm Ed Charbeneau. I'm a principal developer advocate at Progress Software. This is gotta be my 10th or 11th StirTrek. I absolutely love this conference. I try to come back here every year. So today we're going to talk about retrieval augmented generation. Why should we use RAG? What is RAG technology versus CAG or CAG? We'll talk about some key concepts around RAG and discuss the architecture about vector embeddings, vector search, and some of the solutions that we can use to build these type of application architectures. So I want to kind of start at why RAG is important and why we should use it. And it all comes down to making sense of data that we have. I've been at this for quite a while. I've been a software developer for nearly 20 years and a speaker for probably 13 years. And I was at the M3 conference in 2016 rather. And I was talking about the trajectory of AI, machine learning, and big data. And at the time, it was estimated that 44 zettabytes of data would be collected by 2020. And I'm sure we well surpassed that number by now. We collect roughly 400 million terabytes of data every day. And you think of all the things that are being uploaded to YouTube, Facebook, all of the social media and everything else on top of data storage at our enterprises. There's a lot of data being served up to the cloud. It's about 0.4 zettabytes a day. That's an insane amount of data. Back in 2016, I was trying to guess how we would deal with all of this data that we're storing. And I said, how do we make sense of all of these zettabytes of data that are being stored? And the only way to make this possible is through something like machine learning and AI. There's just so much data being stored. It's just not humanly possible for us to manually scan through all of this data that we're collecting. We're collecting so much on a daily basis now. Just for months and years of data, we need these tools to scan through our data and help figure it out. It's just not something that we can do as humans. So this is a technology that is coming out of necessity. So how does RAG technology work and what does it mean? Let's start digging into some of the details. I'm going to start with CAG, or context augmented generation. So there's a couple CAG acronyms here, so I'm going to start with context AG first. This is kind of the lowest level of context augmented generation we can get. The first thing we're going to do in a context AG scenario is we need to upload some data to an LLM, and then we're going to take that data and add it to our prompt. So inside the prompt, all of that data gets tokenized and embedded into vectors, and then it gets processed through the large language model, and then we can do Q&A on it and answer questions. So another example of what that might look like in the wild. This is a talk the same talk that I gave in 2016. I thought it'd be fun to go back and revisit that talk and see how well I did on predicting some of the AI developments that happened over the last 10 years. So I went into YouTube, and there's a little ask button now in YouTube on many of the videos. And that ask button, when you click on the button, it will bring up Google's Gemini. That's their AI assistant. And what Gemini is doing here is it's receiving the transcript from your YouTube video, and they're putting that into the context of Gemini. So they're augmenting the generated text that's coming out of the Q&A session with that AI agent with the data that's in that transcript. So now you can go through that video and ask where you might find certain key events in the video. For this one, I asked, when did the speaker get predictions correct about things that would happen in software development with AI? And it came back and it gave me some instances in the video I could go look up and learn about some of the predictions that I made and how they were relevant to what's happening today. We want to step up this technology a little bit and broaden the amount of data that's available to the AI model. We can do cache augmented generation. So in this scenario, we're going to ingest data into vector memory. So we're going to take in some data, some files, text, whatever that may be. We're going to convert that into vectorized data. And we're going to put that in a lookup table in memory. And when the user has a query, we will search through that data and pull out relevant information, inject that into the context window of the LLM, and then we can process Q&A on that data. So an example of something like this in the real world would be something like Visual Studio's Copilot. I don't know the inner workings of VS Copilot per se, but I imagine there's a lot of this type of thing going on in the background where we have some in-memory cache that's being built up. That cache is going to contain things that are in the agent's memory, previous conversations that we've had, the chat history, and also all of your project files are in there in its cache, so it can quickly search through those and perform tasks on that data. Answer questions about it, write code, all of that. So it's doing this in memory, so it can do it very quickly. So this is where retrieval augmented generation starts. This is the next level up. So we have many files that we want to do this with, not just a couple files that are in memory in a cache, but files that are in a database. So what we're going to do is retrieve those files. And we'll retrieve those files using semantic similarity. And the reason semantic search is used with a technology like this is it's giving us an ability to search through our data using vectors. And those vectors, we'll see an example of this in a few minutes, they allow us to search by similarity rather than keywords. So if we were to look up a product, maybe we were looking for a certain type of cheese or milk, I could go into a search and type dairy and still get cheese and milk products out of that search. So we're searching by this contextual similarity of the data that we have. And once we get that data, we're going to add that data that we pulled out of our database that has a similar meaning to what we asked and put that into the AI's memory. So we're going to put that into the context window of the prompt, and we're going to ask it to form a new response. We're going to generate a response based on the user's question, the context that we retrieved back from our search, and we're going to make a new answer using generative AI that responds to the user's query. So that is what RAG stands for, Retrieval Augmented Generation. It's nerd speak for prompt engineering. Part of this process that is missing from the acronym RAG is the part where we need to store the data somewhere. So a big part of RAG technology is ingesting data. We need to get the data in a format that we can search that's AI friendly. So the way we do that is we take documents in, usually those are text documents, and we'll chunk those up into smaller pieces. Generally this is about a paragraph or several paragraphs of information, and then we'll run that through an embedding process to abstract the semantic meaning from the text that we have in those chunks. And then we'll store that vector information in a database along with the text that was extracted in the chunking process. So we're going to build up a vector database of all this data so we can search by meaning on that data. I showed some use cases earlier of context and cache augmented generation. RAG can serve an even broader range of use cases. So generative AI search is usually the go-to. because the way that we're searching through these databases is using natural language, we can query without having to know special query language to get the data out. So this opens up the data to people through a novel interface, something that is very inherent. Natural language is just human speak. So we can just talk to our AI assistants and they can go find data for us. So generative search is a big one. Business intelligence for unstructured data is another one. So during the process of extracting all of that data with the semantic embedding tools, or the semantic embedding tools, we're able to take unstructured data, PDFs, product information, stuff that's not stored in a relational database, but documents that we normally send other humans. And we can take all of that content in and make sense of it and either create structured data from it or allow the AI to search through it very easily. You can also do video indexing. I showed a little bit of that with the YouTube example, but you could take in and ingest many videos and then index those videos based on the content in them. So you could do exactly what YouTube is doing at scale. Those are just some of the ideas that you could have. You could do product recommendations, all sorts of things. We'll look at some more examples as we go on. So these are our different levels of context engineering. We talked about context AG, cache AG, RAG, and we'll talk a little bit about Agentic RAG as well. So we'll add another layer on top of all of this. And Agentic RAG builds not only the vector database as your knowledge base, but also adds things like knowledge graphs. So we're going to extract entities from the data so the system can understand what people, places, products, and things are and make associations on real-world tangible objects. And then we'll do advanced search on the data. So we'll be able to use AI to take back multiple results and re-rank them to find the most relevant result. And then that agent can present the final result as a response. Also, in an agentic RAG system, you'll see agents being used to validate the quality of the data. So you'll have agents that run in the background, do queries, and then run evaluations against those queries to make sure that the data in the system is valid, stabilized, grounded, because one of the goals of RAG is to search on your own data and remove hallucinations as much as possible from the system. So let's look at some hands-on demos. Well, let's build some stuff. One of the technologies that we're going to start with, we're just going to do some simple embeddings and search using Microsoft extensions. Microsoft Extensions has a couple different namespaces that you can tap to do some AI work. There is Microsoft Extensions Vector Abstractions. This is going to get you some objects that are around vector database, vector objects, and they're not tied to any one system. They're abstractions that can be applied to SQL databases, in-memory, and so on. And it gives you this unified way of working through different .NET applications and different vector stores using C#. The vector store object we'll talk about, vector store data, and vector store search results. There's a QR code on that slide as well that will give you all of the relevant information for this session, not just this one slide, but everything. So take a moment. I'll put that back up there a few times as we go along. So the first demo that I want to do is an embedding search with Microsoft Extensions AI. And I'm going to try to go off of slides for a minute and actually get Visual Studio up and running. So give me one moment while I switch over. There we go. You should be able to see my code here now. So for this first example, I'm going to do embeddings right on my device. So we're not using a large language model at this point to do any sort of AI generation. We're talking about embedding the semantic meaning of some information into vectors so we can search on it semantically. So in this example, I have the Microsoft extensions, vector abstractions installed, and I also have an Ollama server serving up an embedding model. So an embedding model is kind of the flip side of the coin for AI models. Usually when you talk about large language models, they're doing the generative part. This is a model that is for the embedding part. So extracting that semantic meaning out of information to make it available to the generative models. So I've got a local embedding model that I'm going to spin up here with .NET Aspire, or sorry, it's just called Aspire now. They dropped the .NET from it. So we'll let that spin up. And you'll see the embedding models being spun up in the background. And now my app is available. We'll click through to that. So as that app spins up, it's going to take a quick moment to do that because I'm doing the embeddings on my laptop. Embeddings are a little bit less processor intensive than generative AI. If I was doing generative AI, the laptop I have here would grind to a halt. Embeddings don't take quite that much processing power, so I can do a little bit of embeddings on this rather basic laptop. And it can do those in real time for me. The data that I'm embedding, we can take a look at here in this data item, and I'll discuss what some of these attributes are in just a minute. It's a simple object, the data item, that has a title and a description. And these are all grocery store items. If we look at the object itself, it has a title and description, and there's also a vector property here. And these all have attributes on them. This is part of the Microsoft extensions abstractions, vector data abstractions. And we have a vector store key, a vector store data, and the vector store vector. And these are attributes that we can apply to different properties to give them different meanings when we're working with vector data. The main one being the vector store data. This field is the one that I want to create the vector information from. This is the field that I'm going to be doing my search upon. So I want to search through the description. This is going to be my vector store data. And that vector store data will get written to the vector property when I do the embedding. That's a good question.
Yeah, the vector store vector, the 1536.
Yep.
I'm assuming that's the length of the vector, and that would be proportionate to the embedding model?
Correct. So the question was, what is the number 1536? This is the vector length, and it does correspond to the embedding model. When you use vector databases, these numbers are not interchangeable. So that's actually a good thing to point out. I'm glad you did. 1536 is the length that GPT series models use. And if you start your database with a different vector embedding, and then you try to switch to another embedding model later in the process that has a different vector length, you're going to have to rebuild the database from scratch. So that's something to keep in mind if you're going to roll your own. So this model actually it was quite hard to find one that did the right embeddings for the scenario. So the one that does 1536 length is, we can dig into our Aspire app, and it should be listed in Aspire here because I'm running it locally. The local hosted version of this is the hard one to find, rather. You can find this in the cloud easy on Azure. Just go grab the GPT or a small text 3 embedding model off of Azure, and that'll work just fine. This one is the GTE Qwen 2-1 or 1.5 billion. That's the model that I'm using for this. All right, we'll have to step through this a little bit faster. With this semantic search, again, I can kind of fuzzy search on things that I want to get from my data that's in that vector set. So I can search for something like, I want something that makes a good grilled cheese. And I can search on that. And this is only going to pull the records back that have a similar semantic meaning. So this pulled back an aged cheddar. It also pulled back some sourdough bread. And I also wanted to list the scores on this. These scores are the cosine similarity. These are how similar the search term was to the data that's in the search result. So that's how similar they are in semantic meaning. This is pretty important. I like to show the numbers here because they're rather low. I could kind of force this to make higher numbers, but it's important to see kind of what you're dealing with some of these semantic searches. This is one of the parts that's hard to get right with a RAG system is the search aspect of it. If you don't have a good search, you'll see me talk about hybrid search in a little bit. Hybrid search is where you can clean up some of these. You'll see re-rankers being used, where the AI is deciding which of the information, it gets the scores and the semantic meaning back, and it starts to re-rank things to try to pick the best values from it.
I got another question for you.
Yeah, 1 second. Let me try to switch back to slides here real quick. Go ahead.
So I noticed in that attribute that had the 1536, I also noticed that you specified a method for cosine similarity. I'm assuming there would be other methods like dot product and things like that.
Yeah, there's different, the question is about the cosine similarity setting. There are different algorithms that you can use to do similarity, and there's a couple that are supported out of the box by the vector and extensions library.
Okay, cool. So I would imagine if you use like Jacquard similarity versus dot product versus cosine, you would probably get different.
Yeah, there's different ways to analyze those to get different results. So in the basic manual steps to get to retrieval augmented generation, what we would do is I'm just going to manually copy the value out of that aged cheddar description, and we'll paste it directly into an AI prompt. And this might be a little hard to see for folks in the back, so I'll just read it out loud. The prompt says, you're an AI assistant that helps people find information about grocery products. The user has given the query, and then we inject the query here that the user asked for. And then we say, search the database on the topic, or a search on the database has returned the context for this, and then we give it the search results. And then we ask it to form a new answer based on that user's query and the context provided. And that will generate a new answer for us. So we'll get something like this. This might be a little bit easier to see. And it says, for making a delicious grilled cheese sandwich, I recommend using, and it puts the information that it found from the search results into that answer. So let's talk a little bit about scaling from there to small scale RAG. Microsoft has a .NET AI template that's got some interesting bits inside of it. The architecture is Blazor, SQLite with vector database, and then it's bring your own embedding models and large language models. So you just have to have an Azure account, a GitHub account, or some other account that has model hosting, or you can try to do it locally if you have a beefy machine with a graphics card. It supports PDF and text files. It's great to do demos over a weekend type of a thing. This is what the application looks like. So in the demo app that they provide, there is a GPS watch markdown file and a PDF on like wilderness survival or something like that. You can search through those two documents. It also has a pretty decent UI with it. So it's pretty easy to navigate as a user. It's a little bit more user-friendly, and all the code is there, so you can dig through it and figure out which bits you want to get inspiration from to build your own systems. So you can do file new project. You need to install the package for that, but you can do file new project. And again, it's a great learning resource, but it's not meant for scale. They even mention in the resource that you should use something like Azure AI Search to replace the RAG system that is there. This is an example of what that looks like running on device. I'm using cloud-hosted models for this, so it's pretty quick at getting an answer back on the information that's in the PDFs, and you can even open those in the browser. Another technology that you can use to get started, this is more of a medium scale option. I will throw some flags on the play here and give you a warning that this has been in flux ever since I've tried to use it. And every time I try to run my application after they do an update, there are breaking changes. And it's a very gray area as to where those breaking changes are leading. So buyer beware. This changes very frequently, and you have to enable some pragma warnings on your application to get it running, because they warn you not to use it in production. So this is Microsoft Foundry File Search, and the file search portion of it is provided by OpenAI. OpenAI in the file search API can handle up to 10,000 text files. They do have a big list of files types that are supported. All of those file types are essentially text files. They're JavaScript, Markdown, all of those type of things. At the end of the day, they're all text files. So this uses either Azure OpenAI or just regular OpenAI. You can access it through Python or .NET. Again, extremely poor developer experience. Every time I update my NuGet package, I have to go fix multiple problems that they've created. So beware of that. But it is a very scalable option if they would just stop breaking things for a few minutes. So this is a demo that I built with that technology. I actually have a DOME train class on this. And I talk about all the moving pieces in there. And you can make a RAG type of system out of these bits. So you ingest your documents through their vector store, and it will process those bits into and encode them and embed them in the vector store in the cloud. So the vector store is cloud hosted, and then you can ask questions on that data immediately. So this one, I have coffee data. I'm a big coffee nerd, so I've taken in multiple documents on different types of coffee, so I can ask, what are the cheapest coffees? What are the most expensive coffees? Recommend a coffee for me that has a certain flavor profile. Find me a coffee that's decaffeinated. All of those type of things I can just ask in natural human language, and it's going to pull back answers for me. RAG architecture is something that it has quite a bit of difficulty to it. So I'm going to introduce you to one more solution. I will disclose that I do work for the company that builds it, but I am a developer advocate. I try to stay unbiased as possible with these type of things. I genuinely feel like it is a great product. It solves a lot of these problems that you will encounter if you're trying to roll these yourself. So these RAG systems, they usually require many components that have to work together, and those components are by different vendors often. As you saw with the previous example, there's some cross support with Azure and OpenAI, but you still need some other pieces to make that work, such as a user interface. If you want to support something other than raw text, then you're going to need something that can ingest different documents and extract text from different formats. So if you want to do video, the OpenAI APIs alone aren't going to get that for you. You're going to have some sort of system that can extract the transcripts from videos and audio and things like that. You also need to bring, with a lot of these systems, your own embedding models, your own LLMs. The two previous solutions that I showed don't really have a data strategy. So there's no tagging, there's no graph information stored with the data. It's just text files and vector search. And there's also no quality metrics in those. There's no way to evaluate those systems. So if we wanted to go large scale, we need a system that has full control over the hosting environment. Can we host it in the cloud? Can we do hybrid where maybe just portions of it are in the cloud and we're doing parts of it on premises? We need to be able to ingest things that are beyond text files, documents, videos, audio, scrape websites, get all of our data into one place. We need to do hybrid search. Those vector searches, remember those numbers that I showed. The similarity on vector searches can be kind of low at times. People don't always phrase things for their queries the way the data is stored from the documents. So the document may have something described one way, and the user asks a question a different way, and the meaning is just off enough that you don't get great search results. So hybrid search result means you're going to use not only that semantic search, but you'll also do a keyword search. You'll search your graph information, so connect objects together and see how they relate, and then run those through an agent to rank those different search results to find the best ones. We also want to be able to swap models out freely. So we maybe want to run Gemini, Claude, or some other model. And we want something that we can build with quickly and use the tools that we're used to using. So whether you're a .NET developer, Python, TypeScript, etc., you want an SDK that you can use, or maybe you just want to hit the REST endpoints directly. So Progress Agentic RAG is a product that we offer that does all of these things. You can ingest nearly any type of data. It takes your structured data and unstructured data. You can pull anything in with agents. It has that hybrid search that I talked about. It has a quality agent that runs something called REMI. It's a quality evaluation system that's embedded within the cloud infrastructure, that every time you ingest a piece of data, it will run on that data. Every time a query is run from a user, it will address the quality of that response that the user got, and it will continually do this and provide you a score in a dashboard. We also offer the user interface on these things as well. So I've got a quick demo on that. I thought it would be fun to take the Star Trek website and see if I could scrape the Star Trek website and do some RAG with it. It's not the best use case. It's not a lot of data to work with. It's just a couple sessions. It's a smaller one-day conference, and all of the sessions have the speaker data in the same profile, but it worked pretty well. So to do that, we can just go into the Progress Agentic RAG dashboard, and then I'm going to upload the Star Trek's sitemap. So this is a tool within the RAG as a service system. And I can also go in and specify when it visits a specific page. I don't want to go in and ingest the menus, the footers, and all of the non-essential data all of the time. So I'll just use my browser inspection tools to find the main body content of that piece of data, and then I'll just drop a CSS selector in and make sure that we're only grabbing the body content and none of that unessential information. So once I have that, I can go ahead and click the add button, and it's going to go out to the website and just scrape the website for me. So this operation is pretty quick. For a website this size, I don't remember the exact timing on it, but there we go. It's ingesting, processing all of those, giving me status updates on each of the resources that I found. And as soon as that finishes, I want to say it was it was probably around 15 minutes for the entire Stir Trek website. Once that process finishes, I can immediately go into a search box and start asking questions on that data. So I ask here, what time is Chris DeMar speaking? And this search box comes back with Chris DeMar's sessions, one of them starting at 8:30, goes to the machine, another one at 9:30, know your SBOMs for front-end devs. So this search box, I can actually take out of this system and put directly on a web page. This is a widget that we offer from the RAG service. So I dropped it on my personal website just to give it a quick test. It was just 2 lines of code, a JavaScript URL for the CDN, and then a custom web component that you can configure with some settings. Just drop that on a web page, and it was on my website. That's all fine and good, but a lot of us need to build highly customized solutions. So we also have SDKs and APIs to access anything that you saw in the dashboard has an API exposed for it. So if you want to ingest data, if you want to search data, all of the things that you see in the dashboard that can be done there can also be done through an API. So the next thing I built was my own custom website where I could go in and offer a better user experience, tailor the branding and all of that. So I can ask it, when does Ed Charbeneau have a session? And then I'm going to use try to pause that on this screen. So I recorded these because we don't quite have the best Wi-Fi inside of these theaters. But what you'll see is kind of a card interface that's coming out of these. If it'll let me pause. How do you pause a video in PowerPoint? My PowerPoint skills are lacking. There we go. You can see these cards showing up. That card interface is coming from a structured output. So the code to get this out of the database is actually relatively simple. So I'm going to go back to some code. This one's written in .NET. And let me make sure I have the right project here. This is the coffee example. There we go. When I do my search on this Stir Trek data, I'm going to go to the SDK's API and do an ask async. And I'm going to include in the ask async a Stir Trek item type. And what I'm doing here is I'm asking the Progress Agentic RAG system to give me a structured output. So this Stir Trek item is just a POCO object, a plain old class object. And it has a property of answer, and it has a property of sessions, which have a title, an abstract, a time, and a location. And those may have a speaker attached to them. And what this does, it makes the UI portion of it really easy, because I've just created a view model, basically. And when I call this ask method, and I pass in that POCO with it, what the system does is it takes that and breaks it down into a JSON schema, and it passes it with the query to Progress Agentic RAG, and then the Progress Agentic RAG agent will format that into the JSON response that we want back. So it's going to look at that structured object, and it's going to say, all right, I have an answer, I know that's going to go there. And in this data, I have a time and a location that I found. The location happens to be a theater in the scenario, but it's going to use the large language model to figure out where these pieces of data fit in this shape that we gave it. So now when I give that shape back, I can easily go to my UI part of this, and I can extract card interfaces from it. So I have a card here, and I can say, just give me the session.title, the abstract, and the speaker name. And I can just pull that right out of the object using properties. Makes it super simple to use. Let me see if I can get this back to full screen. There we go. All right, so that is a larger scale system that we can use. I was reading this actually just the other day. This was in VentureBeat, and the article was talking about how enterprises are moving away from their current RAG stacks. And the reason for this is because they started with just vector search. They only have a RAG stack that includes a basic vector search, and the answers that they're getting back from those systems aren't the best. So they're moving to a hybrid search approach, like the last one that I showed you, that includes things like keyword searches, graph searching, and additional types of search that try to take the data that's there and make better sense of it before the augmentation process starts and you generate a new answer from it. So that's a shift that's happening now. I just read that yesterday. I thought it would be good to throw in our resources. So you'll find a link to that and some of the other tools that I mentioned there. And I'm happy to take a couple questions, but I think we're about at time. We got about 4 minutes, I think. Yes?
Yeah, can AI do cross-language search? For example, you ingested documents in English, but the user types in a foreign language.
Yeah.
Is it possible?
So it's an excellent question. The question was, can you do cross-language searching with these systems? And the answer is yes. There is a small caveat there. It does depend on what the embedding model is that you used and what languages it supports, as well as the large language model that is doing the generative text and what languages it was trained on and what it supports. So there are some moving pieces there, but generally speaking, most of the modern foundational models will do that for you. I've got some other demos that I've done in the past where we've built forms that agents help you fill out, and you can fill them out using different languages, and you don't have to write any specialized code to have that work. It just, because it's a large language model and it was trained on all these various languages, it can semantically map the different terminologies back and forth. So yes, you should be able to do cross-language searching on these. Any more questions? Yes.
We have Claude that is connected with MCP servers to our Confluence and our Google Docs and our Slack and all these things, and that allows me to ask questions and say, when did X project ship? And we go and search and find it. Is RAG a solution that tries to compile all that down to make it more searchable or more discoverable, or is it, am I better off going the approach we're using?
So the question is, I'm going to try to summarize this the best I can. They're using Claude, and they're asking multiple systems via MCP for different bits of information to assemble questions and reports and things. And is RAG a solution for that? It sounds like the solution that you have in particular might be the right one. RAG would be an additional piece to that. So you could add RAG as an MCP server to what you already have. If there's, say, you have documentation, like if you have a big docs site, you could RAGify the docs site and add it as an MCP, and then add that to the list of tools that Claude is using to do the other analysis that you have.
What's the benefit of Confluence, say, through RAG versus Confluence directly?
So hitting Confluence directly versus hitting it through, you wouldn't necessarily hit it through RAG. You would use that to add additional context to whatever it is you're getting from Confluence. So if you had another system that you needed to be able to search through but didn't have a tool already, you could RAGify. Like a documentation site is a great example. We use RAG for our UI generation tools. So we build UI components. And the APIs and things are specific to our product. So we have a RAG system that can search through all of our documentation, code samples, and all of that. So when people are coding in Claude and Visual Studio, Copilot, things like that, they can plug in our MCP server to it. And then when they need help with one of our products, the Copilot will go out and query our MCP tool, which is our RAG database. And that brings them context back that's relevant to our product and then fills in the blanks that the large language model is missing through its training. Okay, well, I think we're at time. If you have any more questions, I'll take them offline. Thank you very much.